Alright, so in this video we're going to take a look at the binary search algorithm. So before we get into the implementation for it, we're going to do a little conceptual demonstration of exactly what this algorithm is meant to do and why it is that this algorithm is actually preferred over the sequential search. So to start off with, we'll imagine that we have our array. Go ahead and split this up. Say maybe something like 6 items for this one. Put all that together. Okay, so you've got your array, say one with 6 items here, and we want to imagine that we've got some combination of values. We'll do unique values at each location for this. So for this one, I'll keep it simple and just use the numbers 1 through 6. So we'll do 1, 2, 3, 4, 5, and 6. Okay, so once you've got your 6 numbers, you want to do a lookup for a particular number. Say you want to try to find the number 5, for example. So when you do a binary search, the way that it's going to work is that it's going to see the 2 endpoints, see the 1 and the 6 for this array, and it's going to find the middle of it. So since this is even, it doesn't really have a perfect middle. So instead we're going to go with the next best thing, which is either one of these numbers next to it. So we'll go with the number 3. So we're going to look at the number 3, and we're going to see if that is equal to the number that we're looking for, which is 5, or if it's either less than or greater than 5. So in this case, we see that 3 is less than 5. So if 3 is less than 5, and the way that this array is set up, that immediately tells us that it can't be this 1, 2, or 3. So this entire half of the array is immediately eliminated. So then the next time, we're going to look at just what's left of that. So we're going to go ahead and just break it off right here, and instead only focus on this upper half. So we see here, we've got 4 and 6 as our 2 endpoints. We're going to go to the middle of that. And at the middle of this, we're going to see that we have the value 5. So this is immediately going to tell us that this was our input. This is the value that we're looking for. So we were to find that on just 2 searches. So we only had to look at the number 3 and the number 5 to find it in the array. So imagine that compared against the linear search. If we do a linear search, we have to start from the very beginning, and we see, okay, 1 is not 5, 2 is not 5, 3 is not 5, 4 is not 5, and then finally we're going to find the number 5 after doing 5 searches through it. So this is just with 6 items. Now imagine that instead you're working with, say, a large database. Say maybe if you're doing, I don't know, a fairly large, maybe like a global scale e-commerce website, and somebody wants to be able to look up a particular item on your in your shop for your e-commerce site. You're gonna have millions of different items that you're offering, and they need to be able to find that one particular item as quickly as possible. So you can kind of imagine the difference in scale between using a linear search versus this binary search. There's a huge amount of time that is saved by doing it this way instead. So then of course the question is, how much time are you necessarily saving? Well, in a linear search, you have to step through every one of these, and the most important thing that we want to think about would be the worst case scenario. And in the worst case scenario for a linear search, it's going to be that you have to look through the entire array to find the last item in it, or to find that the item's not there at all. So that's going to take you a number of searches through this array that's equal to the number of items in it, which would be, we could represent that as n. So for a linear search, this is going to be equal to n searches. Okay. But with this binary search, well, we could see that it only took us 2 to get to this 5, but that doesn't necessarily tell us exactly what the math behind this is. Well, the way that it's going to work is that essentially, as you look through this, you're basically folding the number of items in half. And when you do this operation of folding it in half, it's basically the equivalent of taking what is known as the log base 2 of the number of items in the array. So I don't think there's going to be an easy way to represent that here. We'll just go ahead and show it as log base 2 of n. And this is going to be for the binary search. Okay. So to give you a general idea about this, if we're working with 6 items, if you want to get the log base 2 of 6, we'll go with the next highest thing. It's essentially looking at powers of 2. So the next highest power of 2 from 6 would be 8. If we get log base 2 of 8, that would give us 3. So in the worst case scenario, when you're looking for an item in this array, it would take 3 searches to find it, or to identify that the item is not in the array at all. If we do this with, say, let's say you're doing it with like 100 searches, in that case then the highest power of 2 would be 128. So at that point then that's going to be 2 to the 7th, so that would take 7 searches in the worst case scenario. Just to give you a general idea about how you would go about calculating the efficiency of this particular searching algorithm. Okay, so now that we've talked a little bit about the conceptual idea of a binary search, let's go ahead and actually try to implement this. So I have this selection sort code open right now, and the reason that I do is because there's one additional slight issue with a binary search that I kind of left out. There's a particular requirement for it. So if we look at what I've got right here, we've got the numbers 1 through 6 in ascending order. Imagine that these numbers were scrambled up. Well, if I have the 6 over here, and I say, okay, I want to look up the number 5 again. If I come right here, and this is a 6, well, that doesn't really communicate to me enough information about where 5 is relative to that 6, because of the fact that things aren't in some kind of order. So before we can actually use a binary search, we have to sort the array. So unlike the linear search, where we can just do a search no matter how the data inside of that array is organized, with a binary search, it must be sorted before we can actually use it. So we're going to keep the selection sort code handy. We're going to need this in a moment, since we need to go ahead and take this and move it into our binary search program, since we're going to have to sort the array before we can search in it. Alright, so we'll go ahead and create a new program, or you can create a new project if you're in an IDE. Go ahead and save this. I'm going to call this one binary search.java. So this will be a public class, binary search. Go ahead and make our main method. So we'll have our public static void main. And for this one, there's a couple of different things I want to do. So I'm going to, rather than create my own particular array for this one, instead I'm going to use a random number generator to just generate a random set of 10 numbers for me. So I'm just going to do it with 10 numbers in this case. I am then going to use the selection sort to sort that array of 10 numbers, and then we'll go ahead and ask the user to specify a particular number that they want to look up in the array, and then we'll apply the binary search to go find that number. Okay, so if we're going to do that, we'll go ahead and import the random class. So we're going to import java.util.random. Once we've got that, we'll go ahead and make our random object. So I'll have a random rand. We'll make this equal to a new random. We can then go ahead and use a for loop. So say for int I equal to 0, I less than, in this case we're going to do it for 10 items, so if we start from 0, go up to 10, and we'll say I plus plus. And right here we're going to go ahead and set up some code to just generate random numbers and put those into an array. So we'll also go ahead and make this array. So we'll have our int array, call it numbers. This will be equal to a new int array of size 10. So I'm going to go ahead and initialize it by just using the new keyword and just construct essentially an empty integer array. So I can go ahead and just populate it with these 10 random numbers. So then right here what we're going to do, we'll say numbers at the position of I. So since I started at 0, goes up to 9, we can use that as our index essentially. And this will be equal to a new rand.nextInt. So we'll use the nextInt method of rand to generate our random integers. And in this case, I'll do random integers from, let's say, 1 to 100. So I'm going to use an upper bound of 100. So this much right now will give me random numbers from 0 to 99. and then I'm going to add 1 to this. So now I get random numbers from 1 to 100. Okay. The next thing I want to go ahead and do is just print this array out. The way that I'm going to do this, it's not really going to look that pretty, but essentially what I'm going to do is just have it print out each one of the numbers with a space separating them. So we're going to have another for loop. We'll do something like this, and for this one we're going to just go ahead and do a print statement. So do system.out.print, and we're going to go ahead and print out each one of these numbers plus a space. Okay, so we'll go ahead and compile this and run it a couple of times just to see the sequence of numbers, to also double check to make sure that I'm not missing anything here. So we'll go Java binary search.java. Okay, perfect. So I think 1 space is good enough to kind of distinguish the numbers. We got like 40, 81, 46, and so forth and so on. If we run this again, we'll get some new sequence of 10 numbers. So it'll be a little bit different every time we do this. Okay. The next thing we're going to do is to go ahead and sort this. So in order to sort this, I'm going to come back over here, and we're going to go ahead and grab all the code that I need to sort it. So I'm going to grab basically everything right here. So you want to go ahead and copy all of this code from your selection sort program, and we'll go ahead and just paste that right here. We're not going to worry too much about the fact that the variable declarations are a bit out of order. Ideally, if you want to clean this up when you're finished, you could go ahead and just take all these variable declarations and move them to the top of the program. But we're just going to go ahead and leave this as it is, so we can kind of keep track of which component of this program we've just finished. So for this one, yeah, so the only thing we really had to worry about was this numbers right here, making sure that the name of our array still matches up properly. For consistency's sake, since I'm using I for these very simple outer loops, I'm going to go ahead and change pause right here to I. Go ahead and save that, and we will go ahead and run this again just to see how this looks. So compile it and run it. Okay. So you can see all of our numbers right there, and then we can see it's sorting right here. And it looks like I see. So there's one other thing we'll have to fix with selection sort that's missing here, which is if the values are equal to each other, it doesn't really account for that properly. So there's an issue with duplicates that wasn't very clear previously. Okay, so we'll go ahead and make this one little correction here, and we'll try this again. One other thing I'm going to go ahead and do is remove this and make this match up with the print statement up here. So we'll go ahead and get it sorted as well. So we'll compile that again. We'll run it. And then one last thing. Let's say right here before we print this, we'll throw in just an extra empty print line statement so we can move this to the next line. And I think now this should cover everything. So we'll compile that, run it. Okay. So now we've got everything set up the way we need it to be. Okay, so we can see our randomly generated array of 10 numbers right here, and then we've got our sorted array right here. So you can see 4, 13, 17, 21, all the way up to 92. With everything in the proper order. We can test this a couple of times. I think the odds of getting another duplicate like we did before. Okay, there we go. So we see a duplicate right here, and now it's actually working properly with that little fix that I had to make. Okay. So at this point now we've got that sorted, quite literally. So the next thing we're going to go ahead and do is ask the user for some input and then do the binary search. So for this next part, we're going to add a scanner. We'll come down here, make our scanner, we'll call it keyboard. This is going to be equal to a new scanner. Again, the scanner is going to be reading from the standard input stream, so we're going to use system.in. We then want to go ahead and create a placeholder variable for the input number that they give us. So I'll have an int, we'll call it input number. We'll initialize that to 0. And then the next part that we're going to have is going to be the set of variables that are related to our binary search. So for this part, let me go ahead and add some extra space here. Okay, so for this part, we're going to include 3 variables that are used to keep track of the thing I mentioned before, which was this beginning and end, so we can determine where the middle is meant to be. So we're going to have a first, a last, and a middle. So I'll have int first. This is going to be equal to 0. So this is basically going to be the 0th position of the array. We'll have an int called last. This is going to be equal to the last position in the array. So if we think about this right here, having this I less than numbers.length, the last position in the array is always going to be 1 less than whatever this length is. So we can just go ahead and use numbers.length minus 1, and that'll cover that one. And then finally we have the middle. And so the middle position of the array is just going to be the average of the first and last. So we just need to add those 2 numbers together and then divide by 2. So we're going to do first plus last, and then divide that by 2. And conveniently, with the way this is set up, you'll notice that we're doing division by 2 with integers. So because we're doing integer division, if we end up getting something like, say, 2.5, for example, because of the fact that we're doing integer division, the 0.5 will be truncated, and it will just be the integer 2. And you can actually see something like that going on right here. In this particular case, we're doing, say, 1 and 6. So if we do positions 0 and position 5, if you add those together, then you get 5. Divide that by 2, and it gives you 2.5. You truncate the 0.5, and that gives you 2. You have 0, 1, 2, and that's why I used 3 earlier for this example. So it's based on the integer division that we're doing to get this position to round out properly when we have an even number of elements. Okay. The next thing we're going to have is an integer that we're going to call position. I'm going to initialize this to -1. This one's going to be used to keep track of the position of the element if we find it in the array. So initially it's going to be -1, just like I did for the sequential search, where we use -1 as a sort of dummy value that might at the end tell us that we didn't find it in the array. Otherwise, if we do find it, it becomes something other than -1. So that's pretty useful for some checks after we're finished with our search algorithm. And then the last thing we're going to include is a boolean, which I'm going to call isFound. This is initially going to be set to false. So again, just like with the selections, the sequential search, we want this to start off false, and then we're going to change it to true if we find the value. That way we can immediately stop doing our search algorithm because we're already done once we find the item. Okay. The next thing we're going to do is actually start constructing the loop for this. So we're going to have a while loop. Again, very similar to what we did for the sequential search. So we're going to say while we have not found it, so while not is found, and while in this case we're going to say as long as this first is less than or equal to last, then we'll continue to search for it. And the reason that we're going to do it this way is because of the fact that as we search through this, these 2 values, so say we start at position 0 and position 5, as we narrow this down, say in this case where we're looking for the number 5, we narrow that down, so we then go to position 3 and position 5. Let's say that 5 is not the number we were looking for. Maybe I have some other number that's not quite 5. So we'd narrow this down again. It would become positions 4 and positions 5. It wouldn't be there. We try this again, and at that point then they'll kind of cross with each other. And as soon as they cross where the first becomes greater than the last, where they kind of overlap each other, that's the point at which we know that the item is not in the array. Okay. Okay, so then once we've got our while loop, or at least the condition for our while loop set up, we'll go ahead and include the calculation for the middle in here as well. So I've kind of already done it here, but every time we go through the while loop, we're going to have to redo it right here as well. So we're just going to have the same thing. There probably is an order that I could have set this up in that doesn't require doing this, but I will not worry about it right now. The next thing we're going to do is check to see if this midpoint, this middle right here, is the value that we're looking for. So we're going to say if our numbers at this position middle, if this is equal to our input number, then we can go ahead and change our found boolean, or is found. We'll set this to true, and then we can also go ahead and take this position and say this is equal to the middle. Otherwise, if we encounter either of these two conditions, whether it's either greater than or less than, let's say if the value at the middle is greater than our input value, so we'll say numbers middle, this is greater than our input number, then what we need to go ahead and do is adjust one of those two endpoints, either the first or the last. In this case, if numbers middle is greater than our input number, so if we look over here for an example of this, so in this case, let's say we kind of invert it, so maybe we're looking for 2. So when we come to this 3 in the middle, the very first one, we'll see that this 3 is greater than the 2. So that tells us that we want to go ahead and just remove this upper half. So that means we need to change the value of last, this 5 over here. We need to go ahead and narrow that down to right around here. So what we're going to go ahead and do is just change the last value, and this is going to be equal to, we saw that it's everything from the middle up. We want to get rid of all that, so we're going to focus on the next lower position from the middle. So that's going to be middle minus 1. Otherwise, if it's not equal and it's not greater, the only thing that's left is that it must be less than it. So in that case, we're going to do the opposite, where we're going to modify the value of first. We're going to kind of cut off that lower half. So this is going to be everything from the middle down gets removed. So we want to focus on the middle plus 1. Okay. And so of course then once you've modified the last or the first, you come back to the beginning of this while loop. Right here, it's going to see the updated version of first or last, depending on which one of those had to be changed. And so that's also going to change where the middle of that subarray that we're looking at now, where that's going to be located. Okay. And then once you've got all that, eventually this will either find the value, or it's going to reach a point where first and last kind of overlap or cross each other, at which point then we would indicate that we've not found the item. In either one of those cases, eventually this while loop is going to, we're going to break out of this while loop and then move on to the next portion of the code, where we will then just provide a little set of if statements letting us know if we found the item or not. So in the first case, we could say if the position is equal to -1, we can say the item is not in the array. Otherwise, we'll just go ahead and say that the item is at the position of whatever position is equal to. So we'll say the item is at position plus position. Okay. And then one last thing that I kind of left out was right here, was to make sure that we actually include a statement to ask the user for a number to put in. So we'll say please enter a number, and then we'll go ahead and assign that to input number. So we'll say this is equal to keyboard.next int. Okay. Alright, so now that we've got everything set up, we'll go ahead and compile this and see if I missed anything. recompile that. Okay, looks good so far. We'll go ahead and run it. And okay, yeah, so one other thing I'm going to have to fix is adding an additional new line character. So we've got our random array here. We went ahead and sorted it. And so now we'll try to find a number in it. So let's try to find the number, let's say 45. So the number 45 in our now sorted array is at position 0, 1, 2, 3, 4, 5, 6. So I'll put in the number 45. And this item is at position 6. Okay, so that indicates that our logic is working out the way we want it to. One last thing I'll go ahead and do for this statement right here at the very beginning of it, or let's just say right here, do something a bit explicit so we know that we have that new line character. So good there. Recompile that so that it's cleaned up. Okay. We'll test this one more time with a number that's in the array. So let's try the number 94. We know this is ending at position 9, so this 94 is at position 8. So we'll do please enter a number, we'll put 94, and we see the item is at position 8. All right, good. And then finally, we'll go ahead and run this and test it once with a number that is not in the array. So let's say we want to try the number, let's go with something that's bigger than anything in here, so we'll try the number 100. And we'll get the item is not in the array. All right, so that shows that the logic, for the most part, looks like the logic is working out correctly. Okay. All right, so at this point, this is going to wrap up all of the code that I wanted to look at for the binary search, as well as showing even more of a practical usage of the selection sort. So this is going to wrap up this video. Going into the last couple of videos related to arrays, we're going to be looking at a handful of other concepts, including things like finally addressing this string array of args in the main method. We're going to take a look at what are known as var args, which is another way to set up parameters for your methods. We'll also go into a little bit of detail about 2D arrays, and then also very briefly touch on 3D arrays and larger scale arrays than that. And then finally, we'll wrap up everything with looking at the ArrayList class.